Andrew,
Yes.
question for you.
Okay.
You don't have to go back to the slide, but this figure 10, 12, if that does not play a significant part of what we need to.
What figure is that?
10, 12, it's on page,
Oh, yeah, don't stress over that. I'm not even sure why they put that in there.
okay.
All right, homeostasis. What is homeostasis? It's all good. Everything is balanced. Everything is equal. All right. To maintain homeostasis, your fluid intake and your fluid output need to be relatively balanced. Okay. So, where do we get our fluid intake from? Well, from liquids, about 1,600 milliliters. We get about another 700 milliliters from solids. And then we get about 200 milliliters from what we breathe in. So where does it go? Well, we lose about 300 milliliters just from breathing. Our kidneys filter out about 1,500 milliliters. Our colon filters out another 200 milliliters. And our skin evaporates about 500 milliliters.
That mass must be must, right?
I'm sorry?
Mass, is that supposed to be you must
Yeah. Intake and output.
go up, intake, output on the second one? That must
Must, yes, must be close to
be
equal.
close.
Yeah.
Oh, yeah, well, sorry. Spell checker doesn't help you when you spell a wrong word correctly. Yeah, your intake and the output need to be close together. So think about it, and this is important. All right, later on, we're going to be talking about a type of shock called hypovolemic shock, which is the most common type of shock we encounter in the field. And usually it's a result of massive bleeding. All right, hypovolemia, low fluid, you've lost a lot of blood, and that's where your fluid went. All right, but it doesn't say only from bleeding. It's not only from bleeding shock. It's low fluid shock. Okay. So let's say you have a patient who's been sick for 3 or 4 days. All right, they've had some pretty bad diarrhea. So we'll say this number quadruples. We'll say, or in 10 times as much. All right, let's say they put down 2,000 milliliters, which seems plausible. If you have some pretty bad diarrhea, 2,000 milliliters of fluid seems plausible. All right, but because they're sick, they cut their intake by 2/3. All right, nobody wants to eat and drink whenever we're sick. All right, so the output keeps outputting, but we're not inputting. So now we're losing more than we bring in. We're no longer in homeostasis. All right, you can easily get into hypovolemic shock by losing too much fluid. It happens to children all the time.
Hypovolemic disease, could that be a result of dehydration as well?
Absolutely.
But not necessarily.
Dehydration would come first. They're not steps in order or anything, but you would be dehydrated, and then later on you go into hypovolemic shock. We cool with this? Don't get hung up on these numbers right here. That's just to illustrate a point. Electrolytes. Those are salts. Salts, when dissolved in a solution, will break down into ions. Your cells need ions. Ions have an electrical charge, positive or negative. Your cations have a positive charge. Your anions have a negative charge. You cool with that?
I always said cations.
Yeah, I don't know how you really pronounce it. Anybody who's learned about real school knows how to pronounce this?
What do we got about 5 different ways to say it?
They got a list of these things. He has no pulse.
You drop it no more.
That'd be cool if we hook them up to a robot that actually changes lives. And moving arms and stuff.
How we doing with that? Got it? These will come into play later.
Are you going to class next week? I don't need any more.
Probably not.
Andrew gonna quit this school, he ain't gonna like this class, they're gonna be bored.
I can't quit, I'll be when I have a contract.
Andrew gonna call each and every one of y'all, show up, please.
Oh, man.
He's going to come in one day.
I don't know where Pete's gonna get the skeleton, give him one.
What
What is your problem?